Hi, this screencast is about drawing Lewis structures, and we're going to focus on just single bonds. And a Lewis structure is when you have two elements and they share a pair of electrons between them, which can be represented as a single line, that's a single bond, or this same one can look like this with two dots between them, which is the same as a single line. These are both single bonds, and we're going to learn how to decide if we get a single bond and where they go. Lewis structure says the pair of dots between the two symbols represent a shared pair of covalent bond, shared pair of electrons which form a covalent bond. So as the image that I just drew for you was the Lewis structure for HCl, you have hydrogen and chlorine, and there is a pair of dots between them, and then chlorine has additional dots around them. So in this example, the single bond is this line in between, and then the dots around the chlorine are what's called the unshared electrons or lone pairs. So either name is acceptable. You can say that they're unshared electrons, you can say that they're lone pair electrons, but those dots are exclusively attached to the chlorine and they're not shared. Okay, so it says a pair of dots representing a shared pair of an electron in a bond is often replaced by a single long dash. Again, you can have a single line with our dots around chlorine, or you can represent it with two dots that are just on the chlorine. So you can do either version for chemistry. Just be clear when you're making your dots that they do not look just like you rested your pen, but they don't have to go the whole way through the paper either. You can have a couple of different types of formulas. You can have a structural formula, which indicates the kind, number, and arrangement of bonds, but not the unshared pair. For instance, this FF here, the fluorine, the F2, does not show us the unshared pair, when in fact, when fluorine bonds with fluorine, you in fact have electrons that are on each fluorine that are not being bonded, and they are. It's correct to show them, but this is a structural formula. All right, so we need to figure out how to draw a Lewis structure, which is what I've been showing you with the lines and the dots. And the example we're going to do is CH3I. So the first thing that we need to do is determine the number of atoms in the molecule. So step number one is looking at the formula and seeing that we have one carbon, we have 3 hydrogen, and we have 1 iodine. And then we need to figure out the number of dots for each. So if you look on the periodic table, carbon has 4 dots, hydrogen has 1 dot, and iodine has 7 dots. I'm going to go ahead and show you the next step. The next step is to do the math, and we are going to see that carbon would contribute 4 electron dots, hydrogens, there's 3 of them, would contribute a total of 3, and iodine would contribute 7. If you do the math and you add it all up, you get that there should be 14 electrons in this molecule. All right, so step number 3 is what we just did on the other side in its totality. So we had, just to review, we had carbon, hydrogen, and iodine. There was, the formula was CH3I. So there's 1 carbon, 3 hydrogen, and 1 iodine. And if you look on the periodic table at the valence electrons, carbon has 4, hydrogen has 1, and iodine has 7. So I'm going to do the math across, and I get 4, 3, and 7. And when I add them all together, this tells me that I have 14 electrons that need to be in my picture, and that will mean that there will be 14 dots. The dots are electrons, so we need to make sure that we have 14 in our completed molecule. So it tells us here that typically the first element goes in the center. Hydrogen is never in the center because remember in the octet rule, everything needs to have 8 electrons except for hydrogen, which only wants 2. So if you only need 2 electrons, you can't be in the center and have other things bonded to you. Once you have done that, then you're going to fill in dots. So we have a carbon. Our example was CH3I. So we have carbon in the center, and we're going to orient the hydrogens around it and an iodine. And it doesn't matter where you place it. You can put the iodine on the side and the hydrogen on the top. That part doesn't matter. In between each pair of elements, you must have 2 dots. They are sharing a bond. So I placed my 4 pair or 8 electrons around the center atom, and it now has its octet rule filled. And each hydrogen, as you can see, this hydrogen has 2 dots, so it's happy and is stable with its octet. This hydrogen has 2, and this hydrogen has 2. And as we said, the carbon has 8. If you look at this iodine here, iodine only has 2 dots, but iodine follows the traditional octet rule, so it is not completely stable. It needs to have more dots. So I'm going to finish filling in with dots around iodine so that I have a total of 8. And if you look and you count, how many dots do we have in the whole picture? We have 2 here, 2 here, 2 here, 2 there. So this is 2, 4, 6, 8, 10, 12, 14. So how many dots were we supposed to have from the math on the other side? We were supposed to have 14 electrons. We can verify. There's 2, 4, 6, 8, 10, 12, 14. This image is correct. And this image, if you redraw it with lines to show those bonds, would have our 3 hydrogens. This is an iodine, and the iodine has the unshared electrons around it. So the process is sort of simple, but you're going to have to go back and verify the number of dots that you're supposed to have and make sure that everything has its octet rule complete. Let's try another example. You were given SiF4, and we're going to figure out how many dots it needs. So we start by figuring out what elements are in the compound, and we have 1 Si and we have 4 Fs. Looking on the periodic table, you can determine the number of valence electrons. So silicon has 4 and fluorine has 7. So do the math. You get a 4 and 28. So this dot structure needs 32 electrons in it. We're going to put the Si in the center, and we will have the F electrons on the 4 sides around Si. You need to have 2 dots in between each pair of elements. So that gives me 8. And Si has its octet rule complete. So I'm going to put a check mark there so I remember. Then I need to go back and finish filling in the dots around each fluorine. So I'm going to continue dotting so that I have 8 electrons around each fluorine. And as I glance at it, each fluorine has 8 electrons around it. Let's go back and make sure that we have 32 electrons. I'll just mark them this way. There's 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32. So my image now has 32 dots around it, which is the number that I was requested. And if you look at it, and it's a little hard to see, there's a single bond here, there's a single bond here, a single bond, and a single bond. And then the rest of the electrons are all unshared electrons around the fluorine. Alright, so far we've learned how to do single bonds, and that would imply that there are multiple bonds. And just to give you a peek at the multiple bonds, that is where you have 2 pair of electrons shared or 3 pair of electrons shared, and I'm going to do those in a second screencast. So we will talk more about double and triple bonds in a later screencast.